Hi, welcome back to Chem 1802, and this is also for Chem 1806. I'm Dr. Amanda Alaband, and in this little demonstration and experiment, we are going to be talking about electron configurations and how electrons give atoms properties for their ground state and excited states. Okay, so first off, to start this, to give you a little bit of a history background of what we're looking at before we take this on farther into the properties of an atom, I want you to look at this model here. Okay. This is the ground state of the magnesium atom. Okay. Each one of these little twine rings here represents an energy level. Okay. And each one of these white spheres represents an electron. Okay. Now, this green one here is an electron too, but I'm going to be singling him out, so I'm leaving him as a different color. Okay. For magnesium, if you look at the periodic table, the atomic number is 12, so there should, in a neutral atom, there should also be 12 electrons. Okay. So on the first energy level, you have 2 electrons. In the second energy level, there will be 8 electrons, and in the third energy level, you have 2 electrons. All the electrons are in their lowest energy level, so that is the ground state. Now, my straw here is going to represent what happens when we give atoms energy. So if we give atoms some heat, we give it some thermal energy, you're going to be supplying photons to that atom. So this little photon here is going to come in and it's going to hit this green electron. When that photon hits that electron, this electron now has energy. It's going to jump up into a new ring. This electron cannot be in any space in between the rings. It can only be in one of these energy levels. So now this is in its excited state. This electron is not in its lowest energy level, so it has energy to it. Now what would happen is this electron here is going to jump back down or relax back down to a lower energy level. When that happens, it's going to emit off a photon, and when it emits off a photon, that photon's going to have energy, and depending on how much energy it carries, it's going to have a certain wavelength, a certain frequency, and it's going to apply somewhere in the visible or within that electromagnetic spectrum. If this electron has a wavelength of roughly 400 to 700 nanometers, then we can see it in that very, very, very narrow section of the visible spectrum. But it could also be outside of that region. We can see in the infrared or UV light as well. But if I now have a photon with a greater amount of energy hit that electron is going to make a bigger jump and may go to the 4th energy level. But now it's in its excited state again. And the electrons are not all in their lowest energy level. They don't have the lowest amount of energy. So they're not in their ground state. So this electron is going to jump back down to the previous ring. When it does so, it's going to emit off even more energy than what I just showed you before, because there is a bigger jump from the energy level 4 to 2 versus energy level 3 to 2. Okay. So going from energy level 4 to energy level 2, you've emitted off more energy, hence the right my photon is bigger than it was before. And it's going to, again, give off something that carries off a certain wavelength, frequency value, certain energy that's going to fit somewhere within that electromagnetic spectrum. So what we want to show you is how can this be applied to things that you see in real life or at properties of atoms. So if you think about fireworks, why do you see the blues, the purples, the greens, the reds? all of those colors are because you are burning different metals or ions of different metals. So what we've got here is some different candles, and these candles have certain ions present in them. So if you look at a periodic table, all these metals will give off their own characteristic emission spectrum. So they all have different properties. The electrons jump from different energy levels and relax back down to them. They're all different, so they all have their different colors and different emission spectrums. Okay. So if you look really closely, that green one is burning because of a certain element on the periodic table. Because of that color, I have an idea of what it should be. Okay.
What color is it burning?
It's burning a green color. Okay. And Dr. Hathcock is behind the screen too, helping me narrate this. Okay. So if I were to look at, we're gonna, if I can get this one to burn. Okay. Okay. If you look at the one next to it, you see a blue flame. Okay. The blue one has different metal present. Okay. So the green colors are from boron. You might see some bluish green for copper, which is what you're going to see here. Copper will be blue to a bluish green tint. And if you kind of look very closely to the tip of this flame, you can see a little bit of a greenish color to it. Okay. Okay. And if I burn this red one here, if you look at the, there it goes. If you look at the tip of it, you can see that what we call a brick red color, and that's because of strontium. Okay. So I've got boron over here. So boron gives that green color, copper gives the blue color, strontium gives that reddish color that you see on the tip. So again, each atom, each type of metal burns differently. Okay. And if you look closely, this one sometimes can be the hardest one to see, but you should see a purple color in that flame. Okay. And that's due to potassium. And then the last one that I've got here is that orange color. Okay. And so orange is notorious for calcium. Okay. So by just looking at these different colors, I could have an idea of what type of metals are present. And that's going to help me use to identify potentially, if I was giving an unknown, what that sample may contain. So if I see this green color, that sample may contain boron. I'd have to do some additional testing to figure out what the other substance was. But I can use all of these colors to help me identify what potential metal or ions are present. And again, each metal will have a slight variation, or as you can see here, a completely different color.